So here we are back with week 2 homework problem 2, and where we left off at the end of the last video is we were working on part B of this problem. And recall that part B involved a force to the left of 8 pounds, which was expressed as x equals negative 8 pounds, and a force vertically upward of 3 pounds, which was expressed as a 3 in the upward direction. Using Pythagorean theorem, we're able to determine the force of the resultant, 8.54 pounds approximately, and what we have left now is to find theta. Well, again, we have to use the inverse function to find theta because we're trying to essentially undo the tangent function. So remember, the inverse of tangent we call arctangent, so you may see a key that looks like this on your keyboard, or it may say ARCTAN. Those are equivalent. The arctangent of, and here you put in the ratio of opposite over adjacent. So we have to treat this, I guess you wouldn't have to treat this A as a positive distance, but it's probably easiest to treat that as a positive distance and then transform. Your other option is you could use the negative number, but then you just have to be cognizant of the coordinate system. So 3 over 8, and actually, you know what, I will use the negative number because that'll give us the that'll actually give us the correct orientation of the vector. So the arctangent of negative 3 over 8, because that negative symbol can just be pushed from from the denominator to the numerator, equals theta. So now we just use our calculator, or we could also use a trig table, but it's just as easy to do 3 divided by 8, and then we'll make that negative, so here's the plus minus symbol, and then we will use the inverse function, do the inverse, oops, wrong key. That was the log natural that I hit, that L looked like an I. The inverse function of tangent. So there we go, let's try this again. 3 divided by 8, make it negative, inverse function, take the arctangent of that, and there you see the number of degrees associated with that arctangent. So the negative 20 that the calculator is giving us here, you have to imagine crossing the origin. That would mean 20 degrees less than the complete circle, or 20 degrees backwards from the 0 angle. By properties of similar angles, we can determine then that theta is equal to that number without the minus sign, so about 20.56 degrees. Now, keep in mind, that's not the absolute angle of theta, right? Because what we want is we want the angle from the 0 degree mark. So we want this angle, which is the supplement to that 20 degree angle. So the way we'll get angle, the actual direction of this, is we'll do 180 minus that 20.56. And that works out to about 159.44 degrees. So the final vector that represents the second part of this problem, part B, has a length of, or a quantity of, 8.54 pounds, and its direction is 159.44 degrees. Now, part C of this problem is a very similar scenario. You'll notice, though, that they've just switched basically the directions of the forces. Well, that means that basically I can just take this rectangle, or this triangle, and roll it around until I get it in a position such that the arrow with length, the vector with length 3 is pointing to the right in X, and the vector with length 8 is pointing downward in Y. So I don't have to redo all the math here. I can just simply redraw this. So we're going to have, for part C, we're going to have an X force of positive 3 and a Y force of negative 8. Well, the length of the resultant is going to be exactly the same. So that's going to be 8.54 pounds. This included angle, this angle theta, is going to be the same. That's going to be 20.56 degrees. And the only thing really that's changed now is the relative position of this angle. So we said that this vertical force was acting along the y-axis. Well, the y-axis is 90 degrees from 0. So if we take 90 and we add it to this included angle theta, that will give us the direction of this vector. Now, the problem is the assumption would be that the vector is moving away from the origin. So essentially what you'd have to do is find that value and then add to it 180, because what we're trying to end up with is a vector that's pointed this kind of southeasterly direction. So it's basically going to be 90 plus theta plus 180. Well, we can simplify that into 270 plus theta. So the angle of the resultant vector is basically all this distance around, all this direction around the Cartesian plane, and the angle is going to be equal to 270 plus 20.56, which is 290.56 degrees. So to finish this problem, the final resultant vector, all we have to do is plug in its length, which we already knew was 8.54 pounds. So 8.54 pounds at the direction 290 degrees, 290.56 degrees. That's the answer to part C of this. And then the last part of this, part D of this problem, the numbers are different, but it's exactly the same procedure. So we have a force to the left of 13, or I'm sorry, this is a distance problem. We're traveling to the left 13 feet. We're traveling south, so I guess we should use cardinal directions here. We're traveling west 13 feet, then we're traveling south 24 feet. And the question is, if you cut diagonally, what would be the distance, and what direction would you have to head in to intercept the end of the walk that included two components? Keep in mind here that the direction, even though I'm talking about this as though it's south and west, the actual number of degrees is going to be based on the Cartesian plane, which puts 0 over to the right. So first thing, find the length. So 13 squared plus 24 squared. 13 squared is 169 plus 24 squared. That one I'm going to have to punch up. 24 squared, 576. Equals this length, we'll call that length side c squared. So square root both, and again you cannot take the root of a part of a sum. You got to finish the addition process before you take the root. So 576 plus 169, and then we're going to raise that to the 1/2 power to take the root. And we find the length of that diagonal walk is about 27.3 feet. So C equals approximately 27.3 feet. Now, the direction, well, same problem, right? You've got opposite and adjacent. Here's angle theta. So remember that angle theta is always going to have one of its sides with an adjacent label, and one of it's going to reference the other side opposite it. When we use the tangent function, the length of the hypotenuse does not come into play, and we don't want it to, because it's a calculated number. We run the risk of stacking errors if we use a calculated number as the input to the next calculation. So again, you use the arctangent function, so arctangent. Okay, and in this case, it is opposite over adjacent, 24 over 13. And you notice in this case they're both negative, so we could put the negative signs in, but they're going to cancel anyhow. And what does that equal? That equals angle theta. So, using our trusty calculator, 24 divided by 13. And then we're going to take the arctangent of that. So inverse tangent. And that works out to about 61.6 degrees. So, now you got to think a little bit about where we are in the Cartesian plane. So we're assuming that this is our starting point, which would be the origin. Well, that origin is 180 degrees from the 0 mark. So we have to add 180 to angle theta. So that plus 180 is going to give us the actual absolute heading of it, which is going to be 241.6. So 241.6 degrees. So if we were to draw this resultant vector just by itself, it starts at a location, it proceeds in a direction, 27.3 feet, and the direction is 241.6 degrees. Hopefully this has been helpful in trying to get you through the homework. As always, if you have any questions, please feel free to get in touch with me at any of the contacts listed in the syllabus.